Page replacement. What is page replacement? As you have seen that we are having a page table in which we have frame, and here we are having page numbers that we have not shown, and then we have added one more column, that is valid and invalid bit. Valid means if that frame is there in the physical memory or not. If it is there, then we have put a valid bit V, and if it is not there, then there is an invalid bit. You can present valid bit by 1 or invalid by 0, or any convention you can use. So what is the process of page replacement? Firstly, if you are wanting to swap in another uh, page from the hard disk, then firstly you have to choose the victim which you have to thrown out from the main memory. So firstly, the first step is page out victim page. Means the victim page you have selected, then you have to throw it into the backing store, and then change that frame value from here valid to invalid. Now you have put that frame value as invalid, that this frame is not there in the physical memory. And the third step is page in desired page, the page you are requiring from the hard disk, that will be brought in into the main memory, right? And what is the fourth step? Reset page table for new page. Means the new frame is you are getting that this particular page is there in this frame, that will be updated into the page table, and respective valid and invalid bit put as valid. So this is the process of page replacement. So how you are choosing the victim, right? So this is the question. Let's see. So what are the steps? First one is find the location of the desired page on the disk. You have to find out where it is and find a free frame. Then if there is a free frame, you have to use it. And if there is no free frame, use a page replacement algorithm to select a victim frame. Means firstly you have to look at that what is the page fault. Page fault is what are the page you are looking is not there in main memory. Then you have to go into the backing store and route in that page into the main memory. So when you are routing that page into the main memory, firstly you look that if is there a frame in the main memory. If it is there, you will place that page into that frame. Otherwise, you have to choose that which victim you are selecting to page out, means swap out into the hard disk, and then swap in that page you are requesting. So if there is no free frame, use a page replacement algorithm to select a victim frame. That means we are using a page replacement algorithm that will help to select a victim, means on which basis you are selecting that this particular page is not required, that you can send it back into the backing store. And then write the victim frame to the disk. Write the victim frame to the disk, change the page and frame table accordingly. So you have to write the victim frame, that is the updated victim, that you, if you are have any work on that, you have to write it down into the backing store, and then change the page and the frame table accordingly. And what is the next step? Read the desired page into the newly freed frame, change the page and frame tables, and then continue the user process from where the page fault occurred. So here you can see the graph between number of page faults and number of frames. Here, what is the page fault? I told you what is the page fault. Can you brief me what is the page fault? Yes. What is the page fault? Are you there? Anyone? Page
Sir,
fault is?
when we look for a page which does not exist in the memory,
Then we
main
can say
memory.
that there is a page fault for that particular page, right? Understand? Good. So this is a page fault. Now, if suppose you are having only one frame, then this graph is telling you that the page fault rate is 15. And if you are increasing the number of frames, means you are increasing your container. That means you can add more number of pages in, like if you are having 2 frames, then you it is 7. And if you increase further frames, then you can see it is 5. And then you have increased frame 4, then page fault is decreasing accordingly. As you can see here, for the frame number 5, the number of page fault is 4 only. and then it is straight, means after a saturation point, page fault that are there is not either increasing or decreasing. So it depends that this is simple example that suppose you are having 5 guests in your house, and you have to serve the water to your guest, and but the thing is you are having only one frame, means you are having only one glass, and with one glass, how many times you have to travel from the kitchen to the drawing room to serve the guest the water? Can you tell me? If you are having 5 guests and you are having only glass, and you have to serve the water to all the 5 guests, then how many times you have to go to the kitchen and fill the glass with the water and give it to the guest? Can you tell me? How many times if you are having 5 guests? Are you there? Question is clear or not? Students, are you there? Am I audible?
Yes, sir.
Question is clear? My question is, if you are having 5 guests and you have to serve the water to all the 5 guests, but the constraint is you are having only one glass of water, then how many times there is a page fault? Means you have to serve the water to all the 5 guests. 5 times you have to move to the kitchen and go to serve the guest. Exactly 5 times, because you are having only single glass, right? And with one single glass you can serve only one process at a time. Exactly. Understand? So you have to go again and again, and what will happen that you are looking for to go into your hard disk and search if it is there or not. Let me show you one more thing. Everyone is aware what is, let me write, then I will ask. Do you know what is, my screen is visible, computer screen? Do you know what is cache memory? Yes or no? Do you know what is main memory? There is one more thing, your backing store, that is your hard disk. Please be with me so that I can understand that you are listening what I am explaining you. Got it? Are you there? Are you there? Anyone? Anyone? Can just let me know. Are you there?
Yes, sir. Yes, sir.
Okay, thank you. So you are able to see my MS Paint, in which I have
Yes,
made
sir.
one cache memory, then main memory, and the hard disk, and here is the processor. Excuse me. And here is the process. Oh. Sorry for the interrupt. Okay, so here is the processor and cache memory, main memory, and hard disk. So can anyone brief me very quickly what is cache memory, main memory, and hard disk? Come on. Come on, anyone? Come on. You know memory hierarchy? You know memory hierarchy? Come on.
Yes,
Do
sir.
it fast. What is cache memory? It is the fastest one, right? And then we are
After
having main
register.
memory. Yes, and faster than registers is faster one. Yes, registers are there, but for today's consideration, we are not considering that register for the sake of this memory management. So we are having cache memory, right? And then we are
Yes,
having
sir.
main memory, and then we are having our hard disk. And what is the storage capacity of all these three? Storage capacity. Can you tell something about storage capacity? Your cache memory is very small, right? Right? And then you are having your main memory, it is larger than your cache memory, right? And what about your hard disk? It is a very large storage, right? Got it? Everything is there in your hard disk. So you can see the container. Your cache memory is very small, and then you are having main memory, which is larger than cache memory. And then this is your hard disk. Why we say that cache memory is fastest? Come on, please be interactive.
Sir,
Why
because
we
it use
yes, because it
sir
used what?
सर frequently data use करता है सर जो हम लोग
Yes, yes. So it is closer to processor, right?
yes sir closer to processor.
And there will be a very less transition time, right? And there is one more advantage that you can see here, that container is very small. If you want to look out something, then it will be very easy to look in that, right? For example, I can say that suppose for take the example of your class, like Ananya is, if I ask you, Ananya is there in today's classroom, it is very small container. You can look at in your class and you can find it out very quickly that Ananya is there in the classroom or not, right? Right? Yes or no? Yes, are you there? Come on, just say
Yes
yes
sir,
or
yes
no.
sir.
Okay. And suppose if Ananya is not there in the classroom, then there is a page fault, right? Then there is a page fault. Then what you have to do, you have to check it with the main memory if it is there in the Ananya is there or not. Means I will take the example that Ananya is in Lucknow or not, or I can say she is in hostel or not, right? Then you will check it with the hostel, that hostel is bigger than your classroom, right? Is it so? Hostel is bigger than cash, is it so? Come
Yes
on.
sir.
Okay. So you have to look at a very large container to find it out that if Ananya is there in the hostel or not, right? And then if she is not there, then you have to look at her native place. If she has gone to her home for the holidays and she is there or not, then it is very large container, that is your hard disk, that Ananya is there in her home or not, right? So if, and of course Ananya is there in her home, so what will happen, Ananya will be requested to come over here. And how it will happen, that Ananya will be go from here hard disk to main memory, right? And then that data will be transferred, and then from main memory through cache memory, right? And once it is done, then what will happen, from cache to this processor, right? Got it? This is the process. Come on, what is happening? Okay, so this is the case. Now you can see if there is a page fault occur, that page is not there in the cache memory. You can find it is fastest because the container is very small. You can very quickly find it out that your friend is there in the classroom or not. If it is not there, you will go and check in the bigger container. That is, if your friend is in Lucknow or not, and if it is not there, then you will check if he is in his house or not. Then if it is there in the hard disk, then you have to route it back into the main memory, and then main memory to cache memory, and then your processor will execute whatever you wanted to execute the process. So now you are able to have the context how this is working. Yes or no? Come on.
Yes sir.
Yes,
Okay,
sir.
you have the clear picture, I guess, now. And if someone asks you why cache memory is faster, you have two reasoning. First one, it is closer to processor. Second one, it is a very small container, and it is very convenient to search something in a very small container. As I explained you previous class also, if I ask you to find the needle in a small box where you put your reel and needles, and if I ask you to search the needle in your bedroom, then the search time will be very high. Got it? So it is a very small container and it is closer to processor also, so cache memory is faster. Okay, so let's get back here where we were. This is number of page fault is here and number of frame is here. So the example we have discussed that you are having Someone's background is making so noise. You can mute yourself, or I will mute you. Come on, okay. Have you? I guess that person is Vaibhav. Are you there? Shall I mute you? Okay, I will mute. Okay then. So what we were discussing that how you can relate this number of page faults and the number of frames, that you are having 5 guests in your house and you are having only one container, that is 1 glass of water. Then how many times you are visiting from your kitchen to drawing room? You say 5 times. Exactly 5 times you have to go and serve the water to your guest. And suppose you are having 2 glasses, then how many times you have to visit your kitchen? Tell me.
Sir, 3 times.
Exactly. And if let me write 1 glass, then you are visiting 5 times, right? If you are having 2 glass, then how many times? 3 times you have to visit. And for 3 glass,
Sir,
you
2
are having
times.
2 times, exactly. And suppose you are having 4 glass, then 4 glass and 5
Sir, 2
guests.
times.
2 times, exactly. And suppose you are having 5 glasses and 5 guests, then how many times?
1 times.
1 time, exactly. Now can you do the analysis here? If you are having 1 frame, then there are 5 page faults. If you are having 2 frames, then you are having 3 page faults. And if you are having 3 frames, then you are having 2 page faults. And if you are having 4 frames, then you are having 2 page faults. And if you are having 5 frames, then only 1 page fault. So here you can see that this is in decreasing order, or you can say sometimes it is parallel also, depends upon the situation. So now you get the fair idea how it is working. Where is that diagram? This diagram. Now, why I explain that example to you? Because I have not written any analysis of this graph. Now, if that topic comes into the examination of page replacement, you have to do the analysis part with yourself only. So if now it depends upon your analysis power, how beautifully you can explain this graph to the examiner. Now I have given you one example, and I can see only few of the students are present in our class, and I have given this example to you. Now you can go for this example in the examination and can get the better marks. And you can see that I am not uploading that reasoning part into the Google Classroom. So those students who will see only lectures for this, they are not able to get that example. Got it? And if I suggest, you can go for some other examples also, because if 17 students are writing the same example for analysis for this graph, then marks will not be up to the mark, right? It is better than those who are not writing the examples. But of course, if I get the same example from all of you, then again marks will be average. So you can think about yourself this reasoning, okay? And see, if any topic you are writing in the examination, whether it is related to computer science or not, always go for examples. If it is Ox or not, if it is there in the books or not, you can think about yourself and can go for the examples, right? So we are done with today's class, and we will discuss in next class with page replacement algorithm. We will discuss 3 page replacement algorithm. First one is like shortage of first. I think it was in there. In where we have seen shortage of first CPU scheduling algorithm. And page replacement are different one. But we will discuss 3 page replacement algorithm. We will see in next class. Okay. So